This mini lesson is on the domain and range. It's pretty short, pretty quick. We're going to determine what the domain of a function is, defined by an equation. So starting right away, let's say we have this particular equation, function f of x is equal to x squared minus 4. So what we have to do is figure out what the domain is. We've got to figure out a couple other parts that we know. Hopefully right away you see this x squared, and that's going to tell you that this is a quadratic. All right, so a quadratic function, we know that a quadratic function is of the form, and it looks like a parabola. This means that any value that I substitute into here, I'm going to end up squaring it, and then I'll subtract 4 from it. Let's just do a couple points just so that we can make sure that we have a firm understanding of what the values would be. So let's say that I substitute a -4, -2, 0, 2, 4, and if we have to do more, we can. So -4 squared, I'm going to substitute that into here. So -4 squared, I take -4 times -4, that gives me 16. So I'll end up with a 16 here. 16 minus 4, that's going to give me 12. -2. -2 times -2 is a positive 4. Positive 4 minus 4 is going to give me a 0. Substitute 0 in here. This is one of my favorite. I put a 0 in there, nothing happens. I've got 0. 0 minus 4, minus 4. Substitute a 2 in. 2 times 2, that's going to give me 4. 4 minus 4, that's going to give me 0. And then I should get 12 here, but let's just double check. If I substitute a 4 in here, I'm going to get 4 times 4, which is 16. 16 minus 4, well, that gives me 12. Now, when we're looking for the domain, all we're looking for is that we want the domain, we want the x values that work. Are there any x values that if we were to substitute it into here, that we would get something that is not allowed mathematically? If I put a 0 in there, I'm still going to get a value. If I put a -5 in there, I'm still going to get a value for this function, f of x. So we went through and we did all of these values, found out what f of x was. We know that all of the x values are allowed, so then that means that my domain, and we'll write it in a couple different ways, we know the domain is the set of all real numbers. The way that you write that in interval notation, well, interval notation, so that means that it's a parentheses because I cannot get to -infinity. It's all values. And then it's going to have a maximum value of infinity. Then we can do set builder notation. So it's the set of all x such that x is an element of the real number system. So I can write it in words, I can write it in interval notation, and then I can write it in set builder notation. Let's take a look at another example. So let's say that we have this one here. I need to determine the domain of this particular function. So to figure out the domain of this function, I have to see what values may or may not work. Again, I have to choose some x values. So I'm going to actually start with an x value that's going to give me some problems. All right, let's say that we go with -6. -6 plus 3, that's going to give me a -3. Square root of -3. I can't do that. So what's the lowest value that I can use? Well, if I use -3, -3 plus 3, that's going to give me 0 underneath. Square root of 0, that's allowed. Okay, let's try a +6. 6 plus 3, that's going to give me 9. Square root of 9, that's 3. So it looks like I'm stuck. I can't go any less than that -3. So now I come over here. So my domain, if I decide just to use the notation like we did before where we just said, it's the set of all real numbers. Well, here it's not the set of all real numbers, but it's going to be anything that is greater than or equal to -3. So now let's use the set builder notation. So the set of all x such that x is greater than or equal to -3. Now if I use interval notation, I'm allowed to be -3, so that means then I use a bracket. -3, we always start with our lowest value, and it can go all the way to positive infinity. I can never have a value of positive infinity because it's not really a number, it's just a concept, it's an idea. So then I use the parentheses. Let's check out another one. So if we have this one, determine the domain of the function. So I've got to see if there are any restrictions that would prevent me from doing anything. So I look at the denominator. Remember that we know that the denominator, okay, the denominator cannot equal 0. I cannot divide anything by 0. It'd be like saying, oh, here, take these 5 markers and divide them into no parts whatsoever. That doesn't make any sense. So what value would make the denominator 0? Well, the denominator is 0 if x is equal to a -4. So then we know that's not possible. All right, so that's the value that's not allowed. I'm not going to worry about the numerator because it doesn't matter what the numerator is going to be, because the numerator is not going to affect the domain. So again, let's come over here. So our domain, if we were to say this using set builder notation, set of all x such that x is an element of the real numbers, except x cannot equal -4. Now if I try to show this in interval notation, again we start with the lowest value of the domain, so the lowest value of the domain is -infinity. I can go up to a -4, but I can't be -4, all right? Or I'm on the other side, and I'm from -4, and I go all the way to infinity. Because I'm not allowed to be -4, but I can be every other value. So this is how we would show that using interval notation. This is how we would show it using set builder. All right, next one. Determine the domain of and range of this function. So again, the domain deals with all the values going this way. All right, these are my x values. And then the range is going to be my y values. Now this one, we're just taking it directly off what we have written here. So I know that I have a solid dot there, I have a solid dot here, so then my domain, and we'll use interval notation, so our domain is allowed to be -4, and it's allowed to be 4, and then it's everybody in between. So our domain goes from -4 to 4, and it includes it. Our range, again, is now going, and let me use a different color just to make this, I don't know if this one will work, but we'll use green. So our range is just going to be from here to here. So again, our lowest value that we're allowed to be, which is 0, and we can go all the way up to 2, and that's included. Try another one. Determine the domain and range of this function. All right, so if I look here, notice I've got the arrow, so that means it goes forever this way. All right, so it's just going to keep going onward and upward. So that means then if I look this way on my domain, I can be any value. But notice I end right here. So my domain, and again, it's going to start at its lowest value. Well, the lowest value, since it continues forever, that's going to be -infinity. My highest value, since it can only go there, because that's where it stops, is 1, and it includes 1. Now when I look at the range, I'm going to look at the y values. So if I look at the range then, I'm starting down here, and I'm moving my way upward. Now notice how this is going up and out, so it'll continue in that general direction. So then it'll start at a low of 0, and it'll go on, it'll go on forever to infinity. And that again is a parenthesis, and that's a bracket. In this case, we have a paren, and then we have a bracket. Okay, got a couple more here just to get ourselves accustomed to it. So determine the domain and the range of this function. So this, okay, This isn't too bad. You should try to do this one on your own. Maybe pause the video at this point and draw it out and do it out. So my domain. So here I am starting here at -3. I've got the arrow at the end, which means that this continues forever this way. So my domain starts here at -3 and it goes to positive infinity. My range, okay, so the range, then I'm dealing with my y component. Let me grab a different color again. So my range, I'm starting here and I'm just continuing to move upward. So therefore I go from 0 to a positive infinity. All right, let's try one more. A little different here. All right, the height h of a projectile is a function of the time t that it's in the air. The height in feet for t seconds is given by the function h of t is equal to -16t squared plus 96t. What is the practical domain of the function? What does the domain mean in the context of this problem? All right, so t is the time. So how long is this thing going to be up in the air? How long is it going to before it comes back down again? So I want to figure out, well, t again is time. All right, we know this is a parabola because of this t squared. The negative, if we remember, a negative means that it's a parabola that opens and closes this way. All right, so what we want to figure out, if this is on an xy coordinate plane, okay, we know that time is going to be 0 when we launch it, and then we got to figure out when it's going to land again. So when am I going to get 0 again? All right, so we probably should try some values. The obvious one is 0. At 0, right, this is going to become 0 here, plus another 0 there. All right, so then the nice thing is that we know with our domain we will start at 0. So I'll even grab my calculator here so that we can make sure that we use the proper values and get things where we want them. You can go ahead and graph this, that would be fine, or you can just try a couple different values. So if let's say I want to do 5 seconds later. All right, so I'm going to take -16 times, in parentheses, 5 squared, which would be 25. And I'm going to add to that 96 plus, or not plus, sorry, times 5 again. All right, so then that would mean that I have a height of 80. All right, so this thing's still going through the air. All right, let's see. So then I should probably keep going, maybe try 6 and see what happens. All right, the other thing that you can do is you can type in the function. So you can go into your graphing calculator into y equals, and you can go through and change the way that it's set up so that you can have it type in your equation, and then you go ahead and try the different values. So let's see, I'm just going to try 6. Okay, so let me get out of the mode that I'm in. So I'm going to re-enter the exact same thing that I did before. So -16 times 36 plus 96 times 6, and I am right back to 0 again. So this projectile, what this is saying is that it starts at 0 seconds, and then by the time that it gets 6 seconds in the air, it's going to be back down at the ground again, gravity. All right, so your domain in this case, your domain is that you can start at 0 seconds, and then you will end at 6 seconds. All right, so what does this mean in the context of the problem? Well, it gets launched at 0 seconds, and it lands, whatever this thing is that we're launching using projectile motion, it lands at 6 seconds. So here's our domain, launched at 0 seconds, lands at 6 seconds, and that we've answered everything here, right? What is the practical domain? Domain 0 to 6. What does the domain mean in the context of the problem? This is the part that most students will have a little difficulty remembering or even talking about. All right, so again, we've come to the end of another one of our videos. Thank you very much for your time. Hope this was helpful, and provide us with any feedback if you have any that you would wish to communicate with us. Thank you, and have a good day.